It is my pleasure to have Mr. Baldev Raj Narang, CEO of Clariant Power System Ltd, with us today. He brings 45 years of experience in the public and private sectors. Mr. Narang leads the company in offering global clients reactive power and power quality solutions. As the chairman of the CAPQ division in IEEMA and a member of the BIS ETD 01 committee and IEC TC 08WG11, he shapes power quality standards. Mr. Narang will speak about challenges of connectivity of renewable energy plants concerning reactive power support from RE plants. So let's welcome Mr. Narang.
We have been working on an issue of grid integration of renewable plants. There has been a major problem, as Mr. Venkatesh also pointed out, regarding reactive power. Initially, what was happening is we were putting on renewable plants without any reactive power support provided by these plants. There was no support whatsoever, whether for even steady state or dynamic state, nothing was there. Although guidelines were there, all the utilities, discoms, they had the guidelines, but nobody was enforcing them. In fact, I wrote about 5-6 years back why we are not having this reactive power support from these people. So this was one problem. And now what has happened is this grid integration, the RE penetration has been increasing. And this will continue to be going like that only. And the other thing is this renewable plants, they are coming at far off locations. And these locations are very weak grid locations. And the issues of integration are there. We had in last 1 year in Rajasthan particularly, where the weak grid is there, the grid strength is not there. The SCRs are also very low in the range of maybe 5 to 10. And we had about 28 incidents of isolation of RE energy. And more than 1,000 megawatt was isolated. So the people who are involved, one of the agencies, Mr. Venkatesh's company only, the Grid India, the other is CTUIL. So the people who are there in the field for this integration, they give the clearance to the renewable plants and they are connected after that only. And as Mr. Venkatesh also said, on model, they meet all the requirements, but in practice, it doesn't work. So the issue, in fact, I was also going to come to that, is that we have a very weak modeling. Our modeling is very poor. And that is the reason we have the fault levels on the SCR values of 5 to 10, which we consider very weak. But if we compare it with Australia, the grid is much weaker. They have fault levels, SCR values of 3, or even in some cases as low as 1.2. But still the incidents are very rare. The way we had the large scale isolations, it is not happening there. So there is a basic problem. And these agencies, they came out with a solution saying that if the RE plants, they come up with Statcoms, the solution will be there. And they made it mandatory. So we were sort of analyzing this thing, whether the Statcoms will provide any solution or not. So what is the actual status is the Statcom is going to give no solution. They are not a magic solution at all. They are not going to increase the grid strength. They are not going to provide any reactive power during the periods which it is supposed to provide. So that is the problem. We are using our inverters. The modeling, as we know on, is not very perfect. And the grid tuning, the grid inverter tuning, the controllers are not tuned properly. And they are just being used as dumb inverters. The inverters are very, very intelligent devices. And they have many capabilities. They can give you reactive power. They can give you active power. They can control voltage imbalance. They can do many other things. But they have a night mode also. And night mode, I don't think if it is activated anywhere in the country, that they don't activate the night mode. We had a client who were paying very heavy penalty, about 1 crore per month, because they were being charged heavily for the night operations. Night, there is no generation, solar generation. And they have a power factor going up to 0.2 leading, very heavy penalty on power factor. The demand going 10 times for their internal consumption, very small, 60, 70 kilowatt only. And the bill was coming like anything. And just because they were not using the night mode, and they are not allowed, nobody is using the inverters for their available capabilities. They are just used for active power. That's all. And we had to give a solution, very costly solution, providing a shunt reactor because they have a long transmission line, 10, 15 kilometers. And there, the capacitors of the line is very high. The power factor goes to leading side. That is the issue. So we had to give a shunt reactor. We had to give a small Statcom, and then only they could avoid these issues. So our problem is that we are not using the inverter. We are increasing our grid penetration with RE energy, but we are not providing the proper solutions. The Statcom, what is being considered as a magic solution, it is not going to work during these periods, because when we have a grid disturbance, there is a fault in the grid. What happens is the fault levels are very low. The Statcoms, they cannot feed the fault. It will take long time before the fault is disconnected, and the system will have the disturbance. And these power PPCs, the power plant controllers, they go out of work. They freeze during these problems, grid disturbances. So they are not available to do anything. So inverter is left on its own, and the inverter has to take care of the whole thing. And we are, as I said, we are not using the inverters properly. We are not having any, you can say, controls or any, or what we call tuning for that period. So they are not able to take care of the situation. And that is why what happens during these fault conditions, the inverters, they have phase loop controllers to sense the disturbances. So they are either they have to trip if they sense it properly, or if the situation is very weak, if it is out of their hand, first they will try to control the voltage. But if it is out of their limit, because the problem is not just the voltage, problem is much deeper. It is the grid strength itself. So it is not able to cope up with that. It goes either into a oscillatory mode, undamped oscillation mode, or it drips and it is just there, but without doing anything. So that is what happens. So what we have to, as I compared in Australia, with despite having a very weak grid, they are not having the problems. They had some issues maybe a year or two back, but just by inverter retuning, they were able to come out of the issue. And suppose you have more than one installation in a location. So these may interact with each other, or the controls may interact. There could be a resonance. So these also can be resolved by only retuning properly. So this is what is missing in our place. And as we go along, we'll have more and more penetration of RE, and the fault levels, fault strength of the grid will keep going down further, because conventional parts are being phased out one by one. We need, and we have, these inverters are today only grid following mode. Statcoms also will be only a grid following inverter. They are not going to solve the problem. They are not going to give inertia to the grid, which is required. The inertia can be provided by the conventional systems like synchronous generators, synchronous condensers, or it can be provided by pump storage, which we don't have much here. Then it could be the batteries connected in a grid forming mode. So these are few things which can provide, and these we have to look that as we increase the penetration, we don't have to just keep adding the solar, wind with just simple inverters. We have to add the batteries also. The battery energy storage systems have to come in a big way, and they have to be in a grid forming mode. Then only the grid strength can be available. And we have all types of inverters in the country today. The quality of the inverter is also very important. In Australia, they only have mainly 3 types of inverters. They call it SMA is one of the maximum use. Then they have in India team, they have power electronics. But we have very assortment of inverters, and there getting an inverter into the country is most difficult thing. It has to satisfy many things. It has to even satisfy that it can work within the SCR levels of 2 or 3 also. We don't have any such conditions. Anybody comes out with an inverter and first of all, the quality is not being maintained or it is not being controlled. The second is the tuning is not there. The modeling is not proper. So we have one of the other problems. And it is just the beginning of our going into the renewable. And at this stage itself, we have issues. The people have planning for 100% penetration of RE over a period of time. And they are planning for that way. And that maybe it is still not in a proper shape. The things are not in a shape today. And this we have two issues. One is that steady state support required for the system. Another is dynamic state. Dynamic state is there during the fault. Mainly, it comes during the fault that low voltage ride through is needed or high voltage ride through after subsequently if the things don't work, it goes to HVRT mode. And in those situations, the simple inverters are not able to do anything. Synchronous condenser, because it has inertia, it is able to sustain for some time. It is able to supply the fault current and it is able to supply the reactive power till the system can be restored. But we don't have any such thing, neither in inverter or even if we go for Statcom, whether we have a Statcom or whether we have a switched capacitor bank, both are equally good or equally bad in a dynamic condition. So the solutions which we are looking for are not the real solutions, I say. Because inverters, what they do is they have to say the gains and time constraints of the inverters, and there has to be good coordination with the power plant, and they have to be well coordinated. Inverter and power, the other system has to be well coordinated. The standard inverter settings, what we have normally here, they may be workable during a storm or in a strong grid condition, but unfortunately, the strong grid conditions, these sources are not there. They are coming at the far end. Maybe 80-90% of the renewable is coming at a point where the grid is not strong. And these conventional plants are being phased out one by one. They are only in the densely populated, maybe, or the earlier areas only. And what we can see is that whichever plants are going out of the service or which are being phased out, there we can use them as a synchronous condenser. The thermal plants can be used as synchronous condensers only. So we have to look at these alternatives so that as we go along, we don't land up in a situation where nothing is working. Then what, as I said, is we need a right technical modeling and we need the proper tuning. This is a very complex process, very stringent process, but here it seems to be very simple. Anybody comes out with a model, it is accepted, it is approved. And in practice, it doesn't work. So this is some of the things. Then what we have is sufficient three-phase fault level is required at each node. Then only the system can sustain these issues of maybe fault. Because this is a variable source. All renewable is a variable source. And the one challenge is that we have to cope up with this variability of the system, the generation, and other is the grid strength becoming very weak. Because conventionally, the transient stability, it is provided by the torques from synchronous condenser, the damping torque, the synchronizing torque is available. But here we don't have anything. And specialized people are there for this modeling and tuning. They need to be available because, as I said, the process is so complex and they are in maybe countries like Australia, despite doing everything, the system may not get approved. With all this, it is an uncertain outcome also is there. So what we need is, an ideal solution is that we should have a reactive power for hybrid. Inverters, what we are having, they don't only have the various capabilities, but they have unused capacity also available. They are being used at maybe perfect, we are using unity power factor. And we don't have any reserve capacity available for this reactive power. Always, inverters are never normally being used beyond 0.8 unit. So there is, if we calculate, see the D curve at 0.8, we get about the 50% of the active power capacity is available at the reactive power, which is not being used. We are not configuring the inverters for a reactive power utilization. So despite this being available, we are having inverters, we are having the reserve capacity, and during lean generation also we get still more capacity, but these have to be configured. These have to be designed for that. So that is not happening. And we are asking for Statcoms, which has been made mandatory. Many plants are ready to be connected, but they are not able to do it because it is a mandatory requirement now that Statcoms should be available. And Statcom is going to do nothing. Still, it is becoming mandatory. And even if a Statcom is there, the problems will remain as it is. So the problem is that we have to see that we have a workable solution, and then only the things will move forward. And if we keep using our inverters as dumb inverters, I don't think we will land anywhere. So we have to use these capabilities, and then only the things will move forward. I think, thank you for here itself. I will close my main discussion because I want to talk only about the reactive power support, which is becoming a major issue today. And because of that, the things are at a standstill. And this Statcoms, which we are asking, which is being mandatory, it is not manufactured in India. We have zero capability of making 33 kV level because that is where the connections are being made. So we have zero capability of Statcoms manufacturing in India. And if it is allowed to be there, mostly it will come from China only because the cost will be the major criteria. Although we have in Europe and all, but ultimately it will be the cost which will determine the source. So it is going to be a maybe we may try to solve a problem, but we may land up in a bigger problem. So that's what I wanted to say. Thank you very much.
Thank you, Mr. Narang, for the detailed talk on challenges of grid connectivity of renewable energy plants concerning reactive power support from RE plants.
For viewers who have joined us today, we would like your feedback and encourage you to stay connected with us via our social media handles. EPI Magazine is now available on Facebook, Twitter, and Instagram. You can also download our app from Google Play and App Store. We also request our viewers to stay tuned for future interactions.